In this video, we'll go through the steps to create a KDB streaming process. Streaming for dashboards requires no external framework and is supported in KDB itself with KDB Tick. This implementation can be found in U.Q, which only uses a few lines of code to create a minimum publish and subscribe pattern powered by KDB. With publishers and subscribers, publishers advertise topics stored in U.T, like quotes and orders. Subscribers call a function U.sub for published topics like quotes. Additional filters can be applied as part of the subscription, for example, a given equity or currency pair. Unsubscribed subscribers are registered in a dictionary U.W, which maps topics to a list of subscriptions. Subscriptions consist of a socket handle and a filter, for example, a currency pair. Once registered, any external change then uses the U.pub function to push updates to a topic. Finally, subscribers can be moved by disconnecting or by calling U.delete. Now let's look at this in dashboards. We'll begin by starting up our dashboards, then going to our dashboards directory, go into our sample folder, and here you'll find the stream.q file. Let's open this in a text editor. Open a new terminal and navigate to the sample folder. We'll run our stream on a separate process on its own port, in this case port 6814. We then define a table to publish, in this case to waves. We load our KDB Tick process with U.Q and then initialize. Our topics are initialized into a streaming table available in U.T. U.W will have a dictionary with waves and no subscribers. Now we need to publish some data. In this example, we will use a sine wave function to populate the data. We will create a series of waves with parameters of amplitude, frequency and phase for wave shape. We now have data available for 6 different waves available for time. We need to publish these rows into our subscription topic waves using the timer function .z.ts to call publish. For every specified interval, there will be a new publish event. Then we set up a snap placeholder for dashboards just to get an idea of what the data is like. Last, we set up a trigger for the timer function. Here we are using 16 milliseconds, which is equivalent to 60 frames per second. So let's visualize this in dashboards. We'll start by dragging the chart.gl component onto our canvas, and we can resize it to fit the screen. We'll create a new data source called stream. We'll create a new connection called stream that is hosted on the same port 6814. We're going to change to our newly created connection, which will have our waves example ready to select. The date is originally keyed by row number, but we want to show it over time, so we will switch that, and now we have our data coming in at 60 frames per second. So what can we do next? When the dashboard loads, we don't want the values to start filling in right from the beginning. So to solve this, we will create a buffer. Now our ring buffer allows us to effectively catch data up to a predetermined size. This then loops around and refills those values. We will then give the ring buffer a size of 10,000 values. With the ring buffer established, we now have a new stream generation function, which saves the new record to the buffer before we return it. The timer function is updated to now call the wave stream wavesgen to keep a buffered version of the last record. Finally, our updated snap function reads from the buffer stream.waves using the location stream.I of the last index item, so it takes the most recent snapshot of our buffer to use in our chart. We can now see in our chart that we have a complete view of our data with new prices streaming in to replace the old values.